In this video, we'll be talking about how to do your correlation analysis in SPSS. Now, correlation analysis is used to describe the strength and direction of the linear relationship between two variables. It identifies the link or bonding between two variables. Okay, now let's take note that in your correlation analysis, there is no causal effect between the variables. In other words, one variable does not have a causal effect on the other variable. Okay, now let's take examples where you can do your correlation analysis. Let's take, for example, an employer of labor force will like to know if increase in the salary of his employees will help to reduce absenteeism from work. Or let's say a sales manager will like to know if there's any relationship between increase in prices and reduction in sales. Okay, now there are two types of correlation. We have the Pearson product moment correlation or the Pearson correlation, and we have the Spearman correlation. Okay, now you do your Pearson correlation when you have to do it continuous variables. Okay, now of course we're going to talk about the assumptions of your correlation, why you must use continuous variables. Okay, and again you use your Spearman correlation when you have to do it ordinal, when your data set is ordinal. Okay, so those are the types of correlation. Now let's talk about what we mean by direction and strength of relationship, direction and strength of the linear relationship between two variables. Okay, now by direction we are trying to determine if how they are related. We are trying to know if as one increases the other one increases as well, or as one of the variable increases the other one decreases. Okay, now we're going to use this as an example. We have our height and weight. Now we have in this scattered plot, we can see that as the height increases, the weight is increasing as well. Okay, now this tells us that the direction of this relationship is positive. Okay, because as height is increasing, weight is increasing as well. Okay, okay, now we can also have a situation where the direction is negative. Okay, like we have in this chart, we can see that as variable y increases, variable s is decreasing. Okay, so this tells us that there is a negative relationship, and as variable s is increasing, variable y is decreasing. Okay, and now how do you know this in your SPSS? When you do your analysis in SPSS, if the relationship between the two variables is negative, SPSS will give you a negative sign to tell you that the relationship is negative. In other words, as one is increasing, the other one is decreasing. Okay, and if the relationship is positive, of course there will be no sign, which tells you that arrow will be equal to 0.820, like we have in this picture. Okay, so that's what the direction in your correlation analysis actually means. Okay, now let's talk about the strength of correlation. Now if we look at this example, we can see that the dots are close to the line of best fit as much as possible. Okay, so if we look at these dots, they are very close to the line of best fit, and this tells us that there is a strong relationship between height and weight. Okay, now the further these dots are away from the line of best fit, that tells us that the relationship between them is weak. Okay, so that's what your strength actually means. And assuming all the dots fell into a straight line, and when you draw your line of best fit, your line of best fit passes through the center of all the dots, that will tell you that there is a very strong correlation between height and weight. Okay, now we have a range. Okay, so now we have this range of we have this interpretation for your arrow value. Okay, now of course your arrow is your correlation coefficient, and this is how you interpret your arrow value. So if, for example, you did an analysis in SPSS and you have 0.00 to 0.1, that tells you that the correlation is there's no correlation. Okay, that means the dots are just far away. Let's take, for example, in this situation the dots will be very far away. Okay, so that tells us there is no correlation. Now if you have a value of 0.1 to 0.39, it tells you there is weak correlation, and that will mean that the dots will be farther from the line of best fit. Okay, and we have 0.40 to 0.4 now, it tells us there is moderate correlation, and when we have 0.70 to 0.89, that will be strong correlation. It means the dots in your scattered plot will be closer to the line of best fit if you should do a scattered plot. Okay, so like I said, this is a strong correlation. Okay, then we have 0.90, we have 0.90 to 1.0. that is very strong correlation, and when you have a correlation of 1, it tells you there is perfect correlation. And when you have a perfect correlation, it means that you're actually comparing two same variables, and as a matter of fact, you should discard the analysis because you are not supposed to compare two same variables. Okay, so that's how we interpret the strength of our arrow value. Now, other things we need to note about our correlation analysis, of course, we've discussed arrow being your correlation coefficient. We're also going to discuss your arrow square and your p-value. Now these three results are all that actually define your correlation analysis. Okay, now when we begin analysis in SPSS, we'll talk more on our arrow square and p-value. Okay, now we're going to carry out a simple correlation analysis with this data set. Now this is a research work among primary school students, and we're going to be doing an analysis, a correlation analysis on the weight and height of these primary school students. Okay, now before we do our correlation analysis, we'll first of all check if there's any linear relationship between them. Okay, of course, first of all, you may want to analyze and see if there's any outlier. Okay, so let's begin by that. Like I said, there should be no outliers, so let's begin by checking if there are outliers in our correlation set. Sorry. Okay, so this is our weight and this is the height. Okay, so let me begin by checking. I'll just check the frequencies if there are any outliers. So this is weight and this is height. Okay, I'll click OK. Okay, so we have this result. Now this is the weight. We have a range of 14 to 61. Okay, now for the height we have a range of 173, of 108 to 173. Okay, so there is likely no outlier considering the lowest and highest values of both variables we selected. Okay, now you want to check the linear relationship between these two variables. Now to do that, we'll come to graphs. Okay, we'll be checking this with a scattered plot. Okay, now to do your scattered plot, you come to, of course, you come to graph, then you come to, it will give you this dialog box of, let me begin again. You come to graphs, you choose chart builder. Okay, let's just click OK, just ignore that. Okay, then it gives you this dialog box. Okay, now I'm going to select my scattered plot. Okay, now it gives me these options. Now this first one is your simple scatter. I'm going to select it. I will drag it and place in this box. Okay, now I can do my scattered plot now. Now I'm going to select, I will select my weight and put it on the x-axis. Now I dragged it, put on my x-axis. I'll select my height, I will drag and put on the y-axis. Okay, So now I will click OK. Okay, now we have this result. Now looking at this result, we can see that there is a strong correlation between height and weight. Strong, by strong I mean if we are to draw a line of best fit, let's say we draw a line of best fit through this, we will find that the dots are very close to the line of best fit. So this tells us that there's a strong correlation. Okay, and looking at this direction too, we can see that there's a positive correlation between these variables. Okay, now if we look at this, if we look at this chart, we can tell that as the height is increasing, the weight is increasing as well. Okay, so there's a positive correlation. So, and there's a linear relationship between these variables. Okay, so now let's carry out our simple correlation analysis. To carry out your simple correlation analysis, you come to analyze, you come to correlate, you come to bivariate. Okay, you come to analyze, you come to correlate, you come to bivariate. Okay, now I will select my two continuous variables. I'll select my weight, I will add. I will select the height, I will add. Okay, now you can see it's already SPSS is already selected because I'm doing analysis on continuous variables. If I were to do an analysis on ranking, on ordinal variables, I will click on my Spearman for my correlation analysis. Okay, so I'm going to click on Pearson. Okay, now you will choose if it is two-tailed or one-tailed. Now you choose one-tailed if you know the likely direction. Okay, so since we know the likely direction, I can actually choose one-tailed, but in case you don't know the likely direction, you choose two-tailed. Okay, but it's preferable we assume we don't know the likely direction. Okay, so let's assume we didn't know the likely direction because we just done a scatter plot, so we knew the likely direction, but let's assume we didn't know. Okay, so you select a two-tailed. Okay, then you click on OK. Now this gives us our correlation, simple correlation result. From this result we can see that weight correlates with height at 0.815. now if we should check our interpretation of arrow value, 0.815 falls between 0.70 to 0.89, and that tells us there is strong correlation, just like we saw in the scattered plot. Okay, so that's our arrow value, and of course this tells us that the direction is positive because there is no negative sign. Okay, this is 0.815, which tells us that there's a positive correlation because we have a positive sign. Okay, so it means as the weight is increasing, the height is increasing, and as the height is increasing, the weight is increasing, and vice versa. Okay, and now we can also see the correlation of height against weight, 0.815. so this is actually same result. They correlate with each other at 0.815. the correlation is positive and the correlation is strong. Okay, now this asterisk tells you at what p-value is your analysis significance. We have here 0.01. okay, now our p-value here is 0.00, that is less than 0.001. okay, so this is actually even less than 0.01. so this tells us that our result is statistically significant. Okay, now this is your n value. Okay, so this is your correlation result. Okay, now we're going to continue and do a multiple correlation analysis. That is when you want to do a correlation involving more than two variables. Okay, so to do that, you come to correlation and you come to bivariate. Okay, now let's select more. Let's select in addition to weight and height, I'm going to select, I will select the size of household, I'll select the number of siblings. Okay, so we're going to check how weight correlates with height, size of household, and number of siblings. We're going to check how height correlates with weight, size of household, and number of siblings. We're going to check how size of household correlates with height, weight, and number of siblings. We're going to check how number of siblings correlates with size of household, height, and weight. Okay, so of course we are doing a Pearson correlation. We are doing two-stage because we don't know the direction this will go. Okay, so and I will click on OK. Okay, so it gives us this result output window. Now we can see our correlation result. Now this tells us that weight correlates with height at 0.815, okay, which we already did in a simple correlation. Now weight correlates with size of household at 0.055. So this tells us that there is a weak correlation between the weight and size of household. Okay, now this is actually a good result as far as this research work is concerned, but this research work is on the nutritional status of primary school students. So this is already telling you that the houses with larger household seem to have they weigh less than those with smaller household. So okay, in other words, the larger the household, based on the effect of their nutrition, the lesser they weigh. Okay, so we can also see that weight correlates with number of siblings at 0.1. So there's also a weak correlation between weight and number of siblings. Okay, well, now let's take example that these are not standard examples. I mean, doing a comparison between weight and number of siblings. Okay, now this is actually we are just checking multiple correlation. Okay, but like I said, you can still actually get a reading from this. Okay, weight with number of siblings, almost the same thing as size of household. So we can still see that the correlation here is weak, 0.1. This is weak correlation. Actually, there is no correlation at all. Okay, sorry, there's no correlation at all. 0.0 to 0.1, there's no correlation at all. Okay, so sorry, actually there's no correlation between weight and size of household and number of siblings. Okay, pardon my mistake. Okay, so for height, this height correlates with weight at 0.815. There's a strong correlation. Now height correlates with size of household at -0.021. Okay, so this tells us that there's a negative correlation and there's no correlation at all. Now if we are to interpret this tells us, one, the correlation is negative, and if there are going to be any correlation at all, it is negative. But having 0.2 tells us that there is no correlation at all. Okay, so and the correlation between height and number of siblings is 0.06. This also tells us that there's no correlation at all. Okay, now if you are going, how will you put this in a Microsoft Word table? Now to do that, you can actually copy this word table into your Microsoft Word. Then you delete this first half of it, because what you have here is same repetition you have here. So you delete the whole of this, and then you copy the rest of this result into your Microsoft Word table like we have here. We can see it. We can see weight, height, your Pearson correlation, weight, height, size of household, number of siblings, and your p-value. Okay, I was to enter the p-value for each of them here. Okay, and you can see the results here: weight, height, size of household, number of siblings. Now, like what I did here, I copied that same table and I pasted it here, and I deleted the other half. Okay, as though you had a line crossing it diagonally. I deleted this upper half and left the lower half because it was like a repetition of results.